Today's presentation is on Chapter 4.1 and 4.2. 4.1 deals with experimental and observational studies. As you recall, there are surveys, observational studies, and experiments. So, an experiment's usually pretty easy to detect. Someone sets out to find out an answer to a question they have, such as, will a particular medication work better than prior medications? Will changing the amount of sunlight on plants change how much they grow? That type of thing is pretty clear. And the conditions that the subjects are experiencing are called treatment sometimes. Observational studies, you just look and see what's already there. You don't impose any kind of a treatment on it itself. So an observational study means exactly what it says. You observe. So consider this headline about student drug testing not being effective in reducing drug use. From that, can you see that the student drug testing is supposed to have some effect on the drug use of students? So the student drug testing would be the explanatory variable, and the response variable would be reducing drug use. Let me give you some facts about it. And then there was a questionnaire given to students, and here are the results. So when you look at these results, we'd like to answer what were the response and explanatory variables, and it was actually easier when you were looking at the headline. It kind of synopsized it for you. And was this an observational study or an experiment? As you recall, they didn't set out to answer this question. They simply asked questions of students. Some of the schools they had done drug tests, some they had not. But those drug tests were not imposed on the school by the person who was doing the study. So to get a clearer picture, let's make this into a frequency table. So you see that I'm dividing each of the numbers by the total on the right-hand side. This is a contingency table. It's being made into a frequency table. So contingent upon whether there were a drug test, we have answers, yes, there was drug use, or no, there was no drug use. The next slide is going to actually show you the results a little clearer. So there it is. 0.37, yes, 0.363, no, for both rows. So they seem to be pretty much identical. So did the drug test cause less drug use or more drug use? Well, it seems like it didn't make any difference. Was it an observational study or an experiment? This is an observational study. And the third question is one I put in. Did having drug tests make any difference? It doesn't appear that it did. Is it absolutely true? Think about that. So it was observational to make an experiment. The researcher would have had to say something like, okay, I'm going to experiment on 10 schools. Randomly pick 5 of them to have drug testing, 5 of them not to. But that was not what was done. And you notice it also said you couldn't leave that to the school, because then it's not random. So in an observational study, lurking variables can affect the results. They can always affect it, but when you have an experiment, you can look for that potential of having them and try to make sure you don't. When observational studies going on, it's already happened, you're just observing what's going on. So if you have something like the number of cardinals in your backyard, and you're looking at juvenile cardinals that are green versus red cardinals that are adults, and you say, oh, I've got a whole lot more of the green ones than I have the red ones. Well, it may in fact be there aren't that many more in the population. It may be that your yard simply has something like buried acorns or some type of food that draws the juveniles that the adults don't care about. So even though the adults may outnumber juveniles in the general population, you're getting more juveniles in your yard because of that unaccounted for factor. Now, we can't absolutely say that there was no effect between, cause and effect between drug testing and drug use. There's an association we see, doesn't seem to be anything definitive, but it might have been our sample, who knows? So let's look at this from the point of view of an experiment. So if they're preferable, why do we ever do anything else? Well, some things aren't ethical. Maybe you expose someone to poison to see how it affects them. Say you do it men compared to women, old people compared to young people, etc. That's not very ethical to do, is it? Nazis did that type of thing. Everyone understood what data they got, but they also condemned it quite heartily. In practice, if you're doing something like a longitudinal study, that's a study over a long period of time, how do you make sure people actually adhere to their treatment assignment? So you may be doing one where it says, I'm going to check and see the effect of a low sugar diet. How do you get people not to eat sugar that are in that group over a long period of time? Not even 50 years. How about 1 year? And then people don't really want to wait that long to get an answer quite often. So, sorry, I'm having trouble saying this one. Anecdotal evidence or stories that you hear. Like, you've heard things like, my uncle would have survived a crash except he was wearing a seatbelt. I heard that when seatbelts first came out. And everybody had that story. But that didn't make it true. It didn't make it false. It was just a story. And it might have been a true story. It might have been a false one. But it's not data. Okay, it was not from a random sample. And they have some famous saying here that I've never heard of, but it makes sense. So if you hear that story a lot of times, it still doesn't make it true. It's still not data. So the census is a survey as opposed to an observational study. An exit poll from an election area, from people coming out of polling place, is a survey. And those differ from observational studies. You're trying to select a sample of people. And for instance, if you're doing it for people who just voted, you really want a sample from people who are voting as opposed to a general sample, because that would include people who are not voting. And that's not going to make much of a sample to get when you're trying to determine who will win an election. But it is also not an experimental type. So they give a few reasons for conducting the census. So there are reasons behind doing these things. And meanwhile, we go on to section 2 about how do you actually make your sample. Well, the sampling frame is a list of all the subjects. And as you can imagine, that can be pretty impossible to have exactly. Like all the statistics students in college in Ohio. You could simply say something like that. That might be one way of having a sampling frame. You might also say from a four-year college, you may say their names if you actually have access to that. So the Department of Education for Ohio may actually have that, where they can list every single student by name, but that would be pretty unusual. So in practice, it's hard to identify every subject in the population. Now that you know your sampling frame, you need to get a method so that you can select subjects from it, and that is a design. So we want a random sample, okay, and we call that a simple random sample. It's the basic one. So one way of doing it is to number all the subjects and randomly pick a number in some way, and that ensures that you have a random sample. So we use technology to do that oftentimes. So you can do things like a personal interview, a telephone interview. Telephone interviews, you can split that up into cell phone and landline, and self-administered questionnaires. Bias is what we have when the results are not representative of the population. Undercoverage is having a sampling frame that lacks representation from parts of the population. So for bias, what if I just ask, suppose I ask people outside a chicken place whether they like chicken or vegetables more. Odds are you're going to find people say they like chicken more, but perhaps not. But that would be some type of bias that could exist at least. Undercoverage, if you do a telephone survey and you don't include landlines, you're probably not getting representation from the older population in the United States. So sampling bias occurs from using non-random samples or having undercoverage. Non-response bias happens because some people, you can't reach them, or you do reach them, say by phone, and they simply hang up on you. Or they answer it but don't answer certain questions. Response bias occurs when they give an incorrect response, perhaps lying, but not necessarily lying in the sense we mean. If you ask students about their drug use or whether they're sexually active, when they're in high school, a lot of times they will answer what they think is the cool answer to use. So that would be a response bias. Sometimes the interviewer asks questions that are not very well stated or purposely misleading. That is also going to induce response bias. Convenience samples. People who volunteer, not a random sample. Like, who wants to test this Pepsi versus Coke? Which one's different? Well, there's a lot of people who would volunteer for that, but there's a lot of people who have no interest in checking it out. So then you're only testing part of the population. So your answers will only correspond to that sample you have, which is not random at all. So go with a simple random sample, not a large volunteer sample. Identify the population, construct a sampling frame, use random sampling, and look for sampling bias of several kinds.